Today we're going to learn about polar coordinates, and we will be learning the conversion from polar to rectangular and rectangular to polar. So polar coordinates, just like rectangular coordinates, are defined using x and y. Polar coordinates are, the components of polar coordinates are r and theta. R is the radius, theta is the corresponding angle. Just like we know how to plot a point. Let's say I want to plot 4, 3. I will look for x as 4, y as 3. So x will be 1, 2, 3, 4, 1, 2, 3. So this is going to be my point here. That's in the rectangular coordinate system. In the polar coordinate system, we will see a polar graph that looks like this. So angles in this case are divided in the increments of pi over 12. So pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. They can be divided in the increments of pi over 4. They can be divided in the increments of any increments, pi over 6. So angles can be in terms of radians or in terms of degrees. Both are okay. So this will be our radius. So we'll say count 1, 2, 3, 4, 5, 6, 7, 8, and then the angles are on the side. Whenever we are plotting the polar coordinates, first look for the angle, then look for the radius. If you go in the clockwise direction, your angles will be negative. Counterclockwise direction, angles will be positive. Clockwise direction, we have negative angles. Counterclockwise direction, we have positive angles. So first look for the angle, then the radius. If the radius is positive, we will go forward. If the radius is negative, we will go backwards. Let's see some examples. The center is called the pole. Center is called the pole. Angles are measured from the positive x-axis. So r is the radius, theta is the angle. To plot the 5 and pi over 4, first thing we are going to look for is pi over 4 angle. So find the pi over 4. So it's pi over 12, 2 pi over 12, 3 pi over 12, which is pi over 4. And then once we find the pi over 4, we're going to go 5 in terms of the radius. So 1, 2, 3, 4, 5. And this is where my point will be located. 5 and pi over 4. First find the angle, then the radius. What if I were to go negative 5 and pi over 4? Then I will look for the angle pi over 4, and to go negative, I will go to the negative direction. Negative 5, 1, 2, 3, 4, 5. Okay, that would be my new point if I were to plot negative 5 pi over 4. Negative 5 pi over 4. Negative 5 pi over 4. Okay, a negative angle would be measured clockwise like usual. Negative angles would be measured clockwise like usual. So just like we learned in the trick, that going to the counterclockwise, we have positive angles. Going to the clockwise, we have negative angles. So if I want to look for negative 3 pi over 4, then I need to go from the counterclockwise direction. So I would go, these are in terms of pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12. 9 pi over 12 is same thing as negative 3 pi over 4, because we can divide both numerator and denominator with a 3. Now my radius is 3, so I'm going to count 1, 2, 3. So this is the point where we'll have negative 3, and a 3 and negative 3 pi over 4. Next, we are trying to plot negative 4 and 2 pi over 3. So first look for 2 pi over 3, the angle 2 pi over 3. That would be pi over 12, 2 pi over 12, 3 pi over 12, 4 pi. So keep going. So there's your pi over 3, 2 pi over 3, 3 pi over 3, and then 4 pi over 3. We were looking for 2 pi over 3. 2 pi over 3 is over here. 2 pi over 3 is here. Once we find the angle 2 pi over 3, we need to count negative 4. So that means go backwards. 1, 2, 3, 4. So this is my negative 4 and 2 pi over 3. So there's many possible representations for the same point in the polar coordinates. In the rectangular coordinate system, if you have a coordinate 1, negative 1, there's no other point that will overlap or lie on the top of this point. But in polar coordinate system, there's many possible points that can take the same spot, same place. So let's look for the example. Number 1, we're looking for 7 and pi over 2. So first find the angle pi over 2, which is here, and then count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is my point 7 and pi over 2. How about negative 7 and negative pi over 2? For that, let's look for the angle negative pi over 2, which is same thing as 3 pi. So that's going to be here. This is my angle negative pi over 2. Now start counting 7 backwards, so I'll be at the same spot again. So both of these points represent the same location. Next we have 7 and 5 pi over 2. Okay, so this is pi over 2. This is 2 pi over 2, 3 pi over 2, 4 pi over 2, and now I'm back at 5 pi over 2. Again, I will go 7 forward, and that's my angle 5 pi over 2. First find the angle, then the radius. If the radius is negative, go in the backwards direction, opposite direction. Next we have negative 3 pi over 2 and 7. So again, negative 3 pi over 2 is going to be the same location here, and this is negative pi over 2, negative 2 pi over 2, negative 3 pi over 2. Once you find the angle, then go 7, which would be 1, 2, 3, 4, 5, 6, 7, and I'm back at the same location. Okay, now keep in mind that in rectangular coordinate system, there's only one way to list a point, but in polar coordinate system, there's many possible ways to list a point or write a point. There's many possible points that will take on the same location. Okay, let's take a point in the rectangular coordinate system and we will be converting it to polar coordinate system. So here we have 3 and 4. We are given the point 3 and 4. We know 3 is the x part and 4 is the y part. So we're going to draw our triangle, right triangle here. And we know the components are cos theta and r sin theta. So from here we know if I want to find out the distance r, if I'm looking for the distance r, I'm going to have to use square root of x squared plus y squared. That's going to give me the r. So r would be 5 in this case. We also know tangent theta is y over x, the opposite over adjacent. The opposite is going to be 4, adjacent is going to be 3, which is theta will be tangent inverse of 4 over 3. Make sure you are in the radian mode in the calculator, otherwise your answer will be not correct. So here's the polar coordinates. This is going to be the polar representation for this rectangular coordinate system. Points 3, 4 is represented as 5, 0.93 in the polar coordinate. 0.93 is the angle in radians. Okay, let's see. So if we were to go from rectangular to polar, we're going to find the r by using square root of x squared plus y squared and find the theta by doing tangent inverse y over x. Okay. All right, theta would be tangent inverse y over x. Now it's very important to plot your rectangular point. Very important to plot rectangular point to understand which theta you will be using. Very important to plot your rectangular point because otherwise your theta can be in the first quadrant, third, second, fourth. So you're going to be careful with plot your rectangular coordinate. That will help you think about the reference angle and the theta you're looking at. Okay, another example. Now let's go on the other way from polar to rectangular. How do we convert from polar form to the rectangular form? So we know so we will be given r and theta now. We'll be given r and theta. X is equal to r cos theta. Y is equal to r sin theta. We can still use our right triangles that we just saw earlier. X would be because x over r was the cosine theta. Cosine is adjacent over hypotenuse. And y over r is the sine theta. So we can isolate the x and y and use x equals r cos theta. Y is equal to r sin theta. And just plug them in there and we have our x and y coordinates. Okay, so to go from polar to rectangular, use x equals r cos theta, y is equal to r sin theta. Let's go ahead and look at two examples. Convert the polar coordinates to rectangular coordinates. So in this case, I'm given the r and I'm given the theta. I want to go from polar to rectangular. So how do we go from polar to rectangular? We just saw that polar to rectangular, x is equal to r cosine theta, y is equal to r sin theta. So x would be the r is square root of 3 cosine of pi over 6. What is square root of 3 cosine of pi over 6? Cosine of pi over 6 is root 3 over 2. Root 3 times root 3 over 2, which is 3 halves. The y comes out to be r sine pi over 6. What is sine pi over 6? Sine pi over 6 is also root 3 over 2. Root 3 over 2. So that would give me square root of 3 times root 3 over 2, which is sine pi over 6 is not root 3 over 2. Sine pi over 6 is 1/2. Sine pi over 6 is 1/2. So root 3, that would be root 3 over 2 1/2. Yeah. Root 3 times 1/2, which is root 3 over 2. Okay, so my coordinates here turn out to be 3/2, comma, root 3 over 2. That's my x coordinate and the y coordinate, and these are rectangular coordinates. So these can be plotted on the xy plane. Next, we're going to convert rectangular coordinates to polar coordinates. Again, it's very, very important to plot the point and see in which quadrant you are. That's going to affect your angle. Because when you do the tangent inverse, you're only going to get the reference angle. So you want to think about in which quadrant you are to get the exact angle. X is -1, y is 1. I'm going to be in this quadrant about here. This is the second quadrant. Okay, so x is -1, y is equal to 1. R, we earlier saw that r is square root of x squared plus y squared. So r comes out to be 1 squared plus 1 squared, which is square root of 2 is r. And then tangent inverse of y over x is equal to theta. So tangent inverse of 1 over -1 is equal to theta. Theta is going to be tangent inverse of -1. So my reference angle is 45 degrees in the second quadrant. The 45 degrees, the pi over 4 is going to be 3 pi over 4. So theta would be 3 pi over 4 because I'm in the second quadrant. Okay, so my polar coordinates in this case turn out to be the r is square root of 2 and the angle is 3/4. And these are the polar coordinates. So we just converted rectangular to polar, and we also converted polar to rectangular. That's all for this video.